So I want you to imagine that there are two people. Okay, and I'm sorry for my drawing, but you have two individuals. One of them is, let's say, a businessman, and the other one is a person whose job is to calculate, so we'll call them a calculator. The businessman and calculator can't actually directly talk to each other, so the calculator is inside of a room, and in this room there's a slit, and they've communicated between each other before the calculator went in here that the only way that they could pass messages is on a sheet of paper, right? Now inside of the realm of the calculator, he has a grid. And the grid is a 5x5 grid. Before businessman and calculator went in, they also discussed the conventions of the grid. And at the top, there's letters. And along the side, there are numbers. And this grid is used by the businessman and calculator to basically communicate, because on this sheet of paper, they can only write 4 words. Okay, so let's fill this grid up very quickly with some numbers. So what are these words that are inside of this that they can pass between each other, right? Because you only have 4 words, so they have to come up with some kind of convention of how they want to communicate. One thing that they're going to need is they're going to need a way to get a value from a position on the grid, right? So they need some way to get a value, right? So if, for example, businessman writes on a sheet of paper, get A1. Once that sheet of paper is passed, and the calculator knows to go and look in, change a different color, go and look over here at A1, and they would basically pass 1. I think I should make that a little bit darker. They pass 1. If the businessman writes on a sheet of paper, get E5, then the calculator knows to go down the rows E and then go to number 5, and over here they would see that E5 is 25. Now the other thing that they need to figure out is a way to write a value, right? So writing a value, right? So they can use the word maybe write. Okay, so when the businessman says write A1, he also needs to be able to tell the calculator what to put in A1, right? So write A1, let's go with 10. And when that's passed, then obviously you would go here and they would go in here and they would write 10 in A1. And if they did the same thing, A10, I'm sorry, right? write E5. Let's go with 3. Then we go to E5. Actually, let's use a different place. D2. Write D2, 3. Then they would go over here and they would write 3 here. Then you need a way to do calculations. So normally, right now, as it stands, the businessman would be the one doing the calculations. Because if I wanted to add what is in A1 to what is in E5, I would write something like get A1, then I would write get E5, right? And then with those two numbers, which would the first time it would have gotten, it would have been 1, second time it would have gotten, it would be 25. Then I would do the calculation and I would know that my answer is 26. So right now the businessman does all this work, right? But that doesn't make much sense for the businessman to do that if who's inside of the box is the calculator. What makes more sense is for the businessman to tell the calculator to do some calculations and then just give him the results because he's a calculator. So what would be a better thing to do is for the businessman, if you wanted to figure out what A1, what the sum of the value in A1 and E5 is, he could just pass in A1 plus E5. This is 3 words. Then the job of the calculator is to take A1 and find what A1 is. And A1 is right now 10. And then E5 and find what that is. And right now that is 25. So it will be 10 plus 25. And then your answer would be 35. This gives us the ability to actually do multiple forms of arithmetic. Using this, we can do plus, minus, times, divided by, and everything. And we know that the calculator will just return the value. So we can now use that to sort of augment the rules we've been using of the language. We've been using get and get. And we've been using write and write. But we can actually change that. And we can actually say that instead of using get, hey, just pass in A1. If you pass in A1, I'll just return you the value of A1. If you pass in E5, I'll just return you the value of E5. I know as a calculator, we're just going to set this convention to say that this is how we're going to operate. Alternatively, down here, when I want to write a value, instead of saying write A1 10, I can simply say A1 equals 10 and D2 equals 3. So doing this is functionally the equivalent of that. And it's just a language convention that we're going to use in this case. So far we have everything working. We understand how to retrieve values from this list. We understand how to write values to this list. And we also understand how to perform our arithmetic calculations on this list, right? So do calculations. We understand that we can do A1 plus D2, and that when we do that, we will get the response 13. And we understand that we can do A1, let's change it up. We can do something like B3 plus C1. And to do B3 plus C1, B3 would be B, go to B, 1, 2, 3, 12, plus C1 C1 would be 3. So we now know that the answer for that would be 15. So now that we have the foundational knowledge, let's get a little bit funky with it. And let's actually do a program. So let's say businessman wants to do a calculation, right? And for this calculation, businessman, let's say, has 5 shoes and has 3 bags and has 1 car and maybe has 10 shirts and 4 pants. And businessman is going to be selling this thing. This is what they have in their inventory. And what they actually want to know is they want to know, well, how many things do I have altogether? Now, how would a businessman be able to do this? Well, businessman would have to say, okay, for the shoes that I have 5 of, let me store them in A1, right? So I'm going to say A1 equals 5. For the bags, let's store it in A2. So A2 equals 3. For the car, we'll continue. We'll store it in A3 equals 1. For the shirts, A4 equals 10. And for the pants, A5 equals 4. And when you pass these all in sequence, what you're going to end up with is you're going to end up with 5, 3, 5, 3, 1, 10, 4. 5, 3, 1, 10, and 4. That's what's ultimately going to end up in the storage inside of this box right here that's owned by the calculator. Now, the next thing that they might want to do is they might want to calculate how many items of clothing they have. And you'll start to see what the problem with this approach is, because in order to calculate how many items of clothing they have, if I were to move this over here and now all you can see is just A1, A2, A3, A4, and A5, how can you easily create a reference to it? For this to work, you would have to have some kind of way that you can track the name of what you're actually trying to do a calculation for and the location inside of the box where that thing is. So in this case, I'd have to know that A1 is actually the shoes, and I have to know that A3 is actually the bags, and A2 is actually the bags, A3 is actually the car, A4 is actually shirts, and A5 is actually pants. When I know this now, for me to calculate the items of clothing, I know that that's going to be A1 plus A4. Then whatever that response is, I need to also add A5. Which when the calculator receives this, the first part, you would basically say A1 plus A4 is 15, and then plus A5 is equal to 19. If you remember our rule, basically we can only ever pass up to 4 things, and what right now we have 1, 2, 3, 4, 5 things right here. 1, 2, 3, 4, 5. So how do we compress that? We have to do it in 2 parts. But if we do the first part of it, and we just say A1 plus A4, our answer is going to be 15. We now have to say maybe B1 is equal to 15. Then after we do that, we can then say A5 plus B1, which would then equal our final result of 19. So you can see that we're actually using 3 steps to move forward. And the reason why we're using 3 steps is because based on our rules over here, there is no rule for us passing in just numbers into the system. Our calculator only understands how to use these the values on this table. So we can amend our rule over here, and we can actually say rule D is that you can always do a calculation with just numbers. So that means that if I pass 3 plus 3, I would just get 6. The calculator does not need to look in this table if he can do the arithmetic himself. And if I pass 3 plus A1, I will get 3 plus 5. The 3 will continue, and then it will just evaluate A1, so that would turn into 3 plus 5, and then the answer would be 8. Using this mechanism, if I go back here, calculating all the clothing items now changes. It's no longer 3 steps. It's now just 2 steps. Step number 1 is get A1 plus A4 as we specified here, and the answer is 15. And step number 2 is simply (15) plus A5. And A5 is 4, so that would be 15 plus 4, which would give you 19. So now you should understand the difference between a location on the table, which is a memory location, and a constant, which is a value that you pass in. A memory location represents a pointer to some place in memory where the actual value exists. So A1 is not what you're adding here. When you say A1 plus D2, what you're really saying is whatever is in A1 added to whatever is in D2. When you say A1 equals to 10, or write A1 10, write 10 to A1, however you want to word it, what you're doing is you're going to take the value of 10 and you're going to store it in the place where A1 is located. And then when you get A1, what you're doing is you're just returning the value that is in A1, which would be 5. So this is all foundational, but none of this really explains what variables are. It just explains how memory is used and how you can do calculations using memory. Where do variables come in? So remember this list that we created here? Remember the problem that we faced over here? The problem that we face is that when we just look at just this list, nothing else, right? Just this guy right here, we have no idea what A5 is, or what A2 is, or what A3 is. And maybe we remember and we have it memorized in our program because we're the ones that wrote the program. But assuming you gave this program to somebody, how would they be able to determine what these values are? All they see is a 5, a 3, a 1. There's no way for them to determine that without actually looking at the index that you've created for it that basically explains what each of these things mean. So suppose we made a change to our program, and suppose we told the person inside the box, or maybe he told us, hey, we don't care where you store stuff. We don't care. All we care is about the fact that we want to add our shoes to our bags, right? We just want to be able to say something like shoes equals 5, bags equals 3, car equals 1, shirts equals 10, and pants equals 4. We just want to be able to say that, right? How would that work? So if you do this, one of the things that's going to have to happen is that rather than you keeping this index, we're now going to move that index into this area, and we're going to tell the calculator to do that. And how is the calculator going to do that? Well, if you pass in something that says, let's go back here. If you pass in something that says shirts equals 1, calculator is going to create another list. They now have to have this, right? As part of their job, as part of what they have to have this other list in there, and this list is totally private to them. And what this list has is it has these words right here, shirts, and then it has what location you want to put these words, A1. And if you say bags equals 3, so it'll have bags, and in bags it'll have A2, and on and on and on. This is not being determined by the businessman, okay? This is being determined by the calculator. And as a matter of fact, the calculator can say, the calculator can decide where they want to put these things. They don't have to put them here, right? So for shoes, they can put it in B1. For bags, they can put it in A3. For car, they can say, well, I'll put that in B5. For shirts, I'll put that in D2. And for pants, I'll put that in D4. Okay, so that's how they're just spreading it out. Now, when you pass in shirts equals 1, what the calculator now has to do is they have to go and find where in this list shirts is. So now they go all the way down to they find shirts. Now call this name here will be name, and name here will be location. And they see that shirts they've put in D2. So they go to D2, and in D2, they're going to put the value 1. The next thing is bags equals 3. So bags, they store in A3. So I can now go here and say how many bags we have? 3. So I'm going to put 3 here. Next thing, car. Car I know is 1. They store in B5. So I'm going to go to B5. And I'm going to put 1. Shoes is in B1. So in B1, I'm going to put the number of shoes, which is 5. Shirts I already have in D2. And I'll use the standard that we have here. So that's 10. Pants is in D4. And so I can erase this and I can put the value of pants, which is 4. So far, so good. By us just adding this here, by us taking this and basically putting it down here and inside, we've now made it so that you can use these memory locations, you can give them names that make sense to you. And you just allow for the calculator to decide where they're gonna put it. As long as they keep track of it, and as long as they say, hey, look, wherever I put it, I'm gonna guarantee that I know and I'm keeping track of it. So whenever you ask for shoes, you're gonna get it, then that's fine. So how does that work to retrieve it? So remember our programming language over here? Over here, we had get value and we said A1. Now instead of A1 or anything like that, we're just going to say things like shoes. And if I ask for shoes, then what will happen is the calculator will take that piece of paper that I've given and we'll look at the internal table that they have, and we'll look to see that there is a name called shoes, and then we'll find the location for that name called shoes, which is B1. Then they will go to B1 and they will return 5. If I ask for bags, they'll follow the same process. Bags is A3. So I go to A3, and so bags will return 3. And the same applies to writing it. As we said, and we just showed it, if I say shoes equals 5, then basically I look for shoes and I find B1 and then I write 5 in B1. Well, what if we add a new one? Let's add a new thing. Let's add TVs equals 2. We have 2 TVs. So you notice over here that this table doesn't have it. There's nothing called TVs there, right? So when the calculator, the person inside of the box, encounters something, TVs equals 2, he has to say, well, you're looking to add TVs somewhere. So I notice that there's no TVs. So let me add a new entry here for TVs, called TVs. Then what he needs to do is go through his entire table and look to see, well, which things here are red. Anything here that's red is something that has already been added. Shoes, bags, cars, shirts, pants, anything that he has set, right? That's in this table. Any value in this table is taken up. Every other area, whether there's a number there or there isn't a number there, is essentially free. Every other number you can add to it. If it has not been in this program been assigned, meaning that he as a calculator has not decided that you gave him a value and he put that value in a specific location, there's no location for it, then even if there's a number there, that number is just going to be erased and a new number is going to be put there. So TVs are 2. So I'm looking here, and most of the time he's going to start at A and just work his way all the way down A, then all the way down B, all the way down C. So TVs is 2. So when I go to A1, I notice there's nothing that's been stored there. So I'm going to just remove that, and I'm going to put 2. So A1 has been taken. And so over here, I'm going to put in A1. And it goes on and on and on. Let's go back here and let's do cats equals 1. Dogs equals 3. Chairs equals 14. Right? So now we have cats, we have dogs, we have chairs. So we go back over here, and as you can see, there's no location for cats. So I'm going to add my cats, and then I'm going to go, is there something in A1? Yes, no. So I can't put it there. Is there something in A2? No, there's nothing in A2 because it's green, and there's none of these things have anything stored in A2. None of these things over here have anything stored in A2. So that means that I can use A2 for cats. So that means I can use A2 for cats. And then I can go here and remove whatever's there and put the value of A2, which is 1 for cats. So 1 goes there. Then the next one is dogs. There are 3. I have 3 dogs. Okay. So we go back and we go through the same process. There's nothing called dogs here, so I'm going to put dogs as a new thing. And then I'm going to once again start counting and say dogs is new, so I need an empty location. Is there anything in A1? Yes, there's something there. Is there anything in A2? Yes, there's something there. Is there anything in A3? Yes, there's something there. Up here, this is A3, has something in it. Okay, so is there anything in A4? If I go through, nope, there's nothing in A4. So I'm gonna decide that A4 is where I store dogs. I'm gonna go to A4 and I'm gonna erase whatever's in A4, and I'm gonna put how many dogs I have, which is 3. So that's how new items can be added to the list, and they can all be used as needed. Now, if I were to say, how many animals do I have? I don't no longer have to say A1, A2, or whatever. I can simply say cats plus dogs. And that's what I'm going to pass together in the note. And when I pass cats plus dogs, it's going to go to the calculator. And for cats, he's going to return the value of cats, no matter where it's located, and that's 1. For dogs, he's going to evaluate the value of dogs, no matter where that's located, it's 3. And then the number of animals that you have that's going to be returned is 4 animals. So this concept of taking aliases and using them to reference locations in memory, like how we did here, is what's referred to as a variable, and is what variables are in programming languages. They are nothing else other than that. So why do they use the word variable? Well, they use the word variable because, as you saw before, you don't always pass a memory location. You can also pass an actual value, which is referred to as a constant value. Why is it a constant value? Because it never changes. 3 is just 3 is just 3 is just 3. You can't use it. You can't write a value to it because it's not actually in memory. It's just a value. Now, for these aliases that we've created, we know memory locations, you can write a value to them. For these aliases that we've created, as you can see, shoes can equal to 5. Bags equals to 3. What happens if I change shoes somewhere down here and I now say shoes equals to 11? Well, every time you pass shoes in, it's going to go here and it's going to look at the memory location. Shoes is located in B1. And whatever is in there, because you've passed in shoes and it knows that you've passed in, and shoes has a memory location. It's not a new location. It's using the same location. It's just going to delete this and put 11 right there. Right? It's just going to change the value every single time. 11. So the value of shoes at any given time could be different. I set shoes here at 5, and somewhere further down, shoes got set to 11. The value of shoes varies. It changes or can change. It has the ability to change. So a variable is, first of all, just an alias. The most common way that a variable is used is to essentially just be a friendly name to a memory location that your program, which in this case is the calculator, is using to store a value that you provided. So going back to our program and our convention, we've specified that you can write values, right? And we've now indicated that a variable is essentially just an alias to a memory location for that value. Now there's one more thing that our program needs in order for us to fully understand what variables are and how they differ from other things. We already know that they're aliases, and that's not going to change. But we do need some way to tell our program, our calculator, hey, no matter who comes after me, once I set this value, I don't want that value to change. Because again, if you look here in this program, say I programmed this, I sent these various messages in, and then somebody else sent these various messages in, and then a final person came in and sent this shoes equal 11. When I come back and I want to now calculate my articles of clothing, whereas before my articles of clothing were 19, now my articles of clothing are 10 for shirts plus 4 plus pants, and before it was 5 for shoes, but it's been changed to 11 plus 11. So now my articles of clothing equal 25. My understanding, based on what I originally programmed and sent to my calculator, is that this should have been 10 plus 4 plus 5. That's what it should have been. But somebody came along after the fact and switched my 5 to 11. So let's say that I don't want that to change. Let's say that I want the number of shoes that I have to always be 5 no matter what, for the length of this program, right? Until I change that value. Then what I need is something in my program, something in my programming language that will let the calculator know, the person inside the box, that this value, when I give it to you, I don't want it to change. Now, we already know that the normal way that we store value is we just use something equals something else, right? So shoes equals 5. So what if we added something like unchangeable, or something to indicate unchangeable? Let's not use unchangeable. Let's use constant, right? So if I say constant shoe equals 5, then what that tells the person inside the box is that when I set shoe to B1, when I set this value to 5, I don't want anyone to be able to mess around with it. So the way I might do it is I might change this table a little bit, and I might add another column to this table. Okay, and over here for my shoes, I'm just gonna put yes. It's B1, and is it constant? Yes. And all of these by default will just be no, right? You don't have to specify it. So here's how the calculator is handling this situation. If you pass me something and it says constant in it, if it first says constant, then it says what it is, or in any order, it doesn't really matter. If I have some indicator that whatever I'm passing to you is supposed to be constant, then when I get in here, I'm going to basically set yes to constant. Now, if somebody over here comes and sets shoes to 11, when I get here and it comes to me, when you pass me the note, or you pass the calculator the note, and they see that someone wants to change the value of shoes, the first thing they check is whether or not this right here is constant. If this is constant, then the calculator is going to pass the note right back to you and say, nope, you can't change it. If it is not constant, then the calculator will do the calculations and change the value as you want. So based on this, you should understand that there is a distinction between two kinds of aliases. You have the alias that changes, and then you have the alias whose value does not change. And then you also have a third kind of thing, which is just a value, right? Which is just a constant value. Now there are more structures, of course, but basically when we're talking about variables, we are talking about this. We're talking about aliases whose values you can change. But just in general, at a higher level, in a more general sense, when we are talking about variables, we are talking about aliases.